Hello everyone, Dr. Data Science here. Welcome to Deep Dive into Keras Lecture 2. In this lecture, we are going to talk about the functional API in Keras. And we are going to see that this functional API is very helpful for implementing hidden layers with different activation functions. And this is something very important because the default way of creating hidden layers in Keras only allows you to create layers with identical activation functions. So let's get started. So in the previous lecture, we talked about the sequential API. And sequential APIs are very helpful to create simple models layer by layer. This means that when you look at each layer, you have an input tensor that is coming from the previous layer, and then you have an output tensor that goes to the next layer. On the other hand, when you're working with the functional API, you have a lot more flexibility to create complex models with shared layers, multiple inputs, multiple outputs, and so on. So the general recipe or formula for the functional API is as follows. You're going to start importing your layers. In this case, you have to import this input layer because we have to very clearly specify the input layer that we have in our model. And then we are going to work with dense layers that we have seen before. And also from keras.models, we're going to import model. And remember that this is a capital M. So as you can see here, you're going to start by defining the input layer using the input layer that we have imported. And obviously, like other layers that you define in Keras, you always want to define the shape of the input that you have to your model, meaning that if you are solving a problem where you have 5 input features, this should be 5 comma. And then after that, you use the dense layer, and the difference with the sequential API is that now we look at this as a function, which means that now we are using this extra parentheses in front of this. So you can think of this as f of x, where x is the input, right? So this is the input layer. And then we get the output, which is the output of the hidden layer. And now this output of the hidden layer will be input for the next layer. And in this case, we assume we have only one hidden layer. Therefore, this will be the input for the output layer that we have. And obviously, the output layer, the number of units or neurons that you put depends on if you have a classification problem on the number of classes, and then you want to use the softmax activation function. So we're going to have another video. We talk about more in detail about activation functions, but right now we are talking about creating models. And here is the very important and key step here. So at the end, you have to be able to tell Keras what is your input layer, or I would say, what are your input layers, and what are your output layers? In this case, we have a very simple case. We have a single input layer and single output layer. So that's why you can see that for inputs, we have only one layer, and for outputs, we only have one layer. However, in general, you can have a list of layers for each of these two arguments, inputs and outputs. So how does this work in practice? So let's here import NumPy and Matplotlib for visualization. And the goal is to create a synthetic data set that consists of 3 classes. And each class here has a mean and covariance matrix. And we are using the multivariate normal distribution to generate 200 samples. And then once we create these samples for each class, we are going to concatenate them using these V stack and H stacks, because the data points that we have need to be stacked together vertically, and for the classes we need to stack them horizontally. And as you can see here, we can use a scatter plot to visualize this data, and you can see that this is the synthetic data set that we have. So I'm going to share the code so you can recreate this experiment and this synthetic data set, but you can see that here we have these 3 classes that we want to classify, and this is a 2-dimensional data set. So in this case, we also want to create a training and test data sets using train test split from scikit-learn. Remember, all of these things are in Python, so you can use scikit-learn, you can use keras, and there's really nothing to be worried or concerned here, as long as you make sure that you, for example, with NumPy arrays or TensorFlow tensors, so that's like the only thing that you have to keep in mind. But anyways, here we have a training and testing data that we symphonically generated. And then the main part is that you have to import keras. From keras.layers, you import input and dense, so the two layers that we need here. And then we import the model from keras. And also here I'm importing accuracy score from scikit-learn.metrics because I want to evaluate the classification accuracy. So what is the goal here? My goal here is to define and train 3 different models using these 3 activation functions here. And in order to simplify this, I create this function which is called create model, and the input argument here is activation. So if I pass the activation, I create this model with the activation. You can see that here we have the two input units in the first layer or the input layer, and then we have a hidden layer with 2 inputs, and in the last layer we have 3 neurons. And we follow the same process that we said, that we have the inputs. These will be input for the next layer, and then the output of this hidden layer will be input for your output layer. So the next thing that we're going to do is that we're going to write this for loop over this choice of activation functions that we have. And this here, so for each activation function, which I call it here this item, I'm going to create this model, compile it. So because it's a classification problem, I'm going to use the categorical cross entropy loss function. And then we are going to train our model on the training data using 40 epochs and batch size 32. So these are all the parameters that you can adjust and change them. But the idea is that you're going to use in this for loop each time 1 activation function. And then at the end, I'm going to evaluate the performance of that activation model that we use in that neural network model on the test data by using this accuracy score. And you can see here that based on what we printed, you can see that the soft plus gives us 0.45, which is really bad. It's less than 50% accuracy here. Exponential linear unit, or ELU, gives us a much better result of 0.71 or 71% accuracy. And then ReLU is even worse, is almost 30%. And because we have 3 classes here, which means that if we do this randomly, we should get very close to 33% or 1 over 3. Right. So the idea here that we want to experiment is that we have these 2 units in the input layer. Can we have 3 branches, and each branch goes to 2 units that they use one of those 3 activation functions that we have. So the ELU, ReLU, and soft plus. And then we can concatenate them. So what this means is that at the end, we are going to have 1 hidden layer that now has 6 units, and they have 3 different activation functions. And then we are going to connect these to the output layer where we have 3 neurons for each class. So here, the only extra thing that we have to do is to import concatenate from keras.layers. And you can see that other than that, everything is very similar to what we had before. So we have to define our input layer, and that's based on the input shape, which is 2 units in the first or input layer. And then here we have the 3 branches that we talk about, right? So each branch is a dense layer with 2 units, and we use all 3 activation functions. And here is the important thing. If you look at here, the input for each branch is the input layer, right? So that's how we implement this, that this input layer goes to the 2 units that they use ELU, to the 2 units that they use ReLU and soft plus, and all 3 activation functions here. And then here, what's really important is that now we can concatenate these three branches together and create technically one layer. And now we're gonna uh, give this as input to the output layer. So that's where you can see this. And we use the softmax. And because it's a three-class classification problem, we're going to use 3 units. And the last step is to use keras.model here to say that what is the input layer, what is the output layer. And then Keras will know how to connect these units or neurons together. And similar to before, we're going to compile, fit the model, and measure the accuracy of this new model that we have using this concatenated layer that we have. And you can see that now we get 88 almost 88% accuracy, which is great, which is much better than the results that we had before. So this was just a very quick example of how to use functional API and why to use functional API.